Hi everyone, I'm Marco Gaido, and this is the presentation of SBAAM, Eliminating Transcript Dependency and Automatic Subtitling. Subtitling is a complex task that involves not only translating an audio content into a text in a different language, but this text has also to be segmented into blocks, and these blocks further into lines, to ease the reading of them by the user. In addition, timestamps have to be associated to each block in order to have the information of when these pieces of text have to be displayed on screen. Since subtitling is a complex task, the traditional approach involves a pipeline of several components. The audio is first transcribed by an automatic speech recognition module that generates the transcripts. These transcripts, together with the original audio, are then fed to a force aligner that provides for each word the start and end timestamps. These and the original transcripts are then given to a block segmenter that segments the transcript into blocks of text and lines and also associate them with the corresponding timestamps. Lastly, a machine translation model translates the content into the target language to generate the final subtitle. In order to streamline this complex pipeline, there have been attempts to leverage direct ST systems. In this case, the audio is fed to a direct speech translation model that generates two outputs. On one side, it generates the target translation already segmented into blocks and lines. On the other, it generates the transcription with the associated timestamps. A timestamp projection module then takes these two information and generates the final subtitles in the target language with the corresponding projected timestamps. However, this solution still requires the generation of transcripts, and this has several limitations. On one side, it reduces the efficiency of the system since there is a next generation step. On the other, with this solution, we cannot support languages that do not have a writing system and are only oral. For this reason, we propose the first direct subtitling architecture that does not leverage transcripts in any phase of the inference phase. In our architecture, we have an encoder-decoder system that takes audio as an input and generates translation with block and line boundaries. In this way, we already have the subtitles segmented into blocks and lines. However, we still miss one step. So the question that remains to be addressed is how to assign timestamp to blocks. And in this work, we propose to leverage the cross-attention between the encoder and decoder to align the text and audio. And in particular, we designed the speech block attention area maximization method. SBAAM assigns to each block of text a temporal span and assigns it in a way that tries to maximize the attention score within the rectangular areas that are formed by the block tokens on one side and on the other to the associated temporal spans. Once each block is associated to the temporal spans, maximizing these attention scores, we obtain the corresponding timestamps. In order to evaluate the quality of our solution, we leverage two metrics. First of all, we use SBAAM, which is a tier-based holistic metric for subtitling that tries to account not only for the translation quality, but also to how well the text has been divided into different blocks and lines, and also to the timestamp assignment. This metric has been validated to correlate well with humans. However, we know that it's not very sensitive to timestamp errors, unless they are huge. Since one key element of our solution is the timestamp assignment process, we introduced a new metric, subsonar, that is complementary with SBAAM and is very sensitive to timestamp assignments. On the other side, subsonar is not very sensitive to translation quality, and for this reason, it's complementary to SBAAM. Subsonar takes the SRT, or the subtitle generated by the system, and on one side, it takes the audio corresponding to the timestamp for each block. It takes this audio, it feds this to the Sonar speech encoder, and obtains the corresponding embedding. On the other side, it takes the corresponding text, it feds it to the Sonar text encoder, and obtains the corresponding embeddings. Lastly, the audio and text embeddings are compared with the cosine similarity to obtain a score of how well these two elements are aligned. Looking at the results that are obtained averaging over 3 test sets and 2 language pairs, English to German and English to Spanish, we see that both in terms of sub-air and sub-sonar, our system is capable not only of outperforming the previous direct approach, trained on the same in the same data condition and using the same model, but is also capable to outperform the best production system that we were able to find. We further evaluated the quality of our system with a post-editing effort. In this case, we required post-editors to change only the timestamp that were assigned by the automatic systems. As we can see, in the previous direct approach, post-editors have changed 39% of the content, while with SBAAM, only 18% of it have been changed. In addition, when timestamps are changed by the post-editors, the time shift of the previous approach is also much higher than the one in SBAAM, validating the quality of our tool and also showing that Subsonar works well in estimating the timestamp assignments. All in all, we have presented the first direct subtitling system that does not require transcriptions and to generate the final subtitle in the target language, including their timestamps. Also, we introduced a new metric to evaluate timestamp accuracy that we named Subsonar. We validated our solutions with a post-editing manual evaluation and also with automatic metrics, showing that our solution is able to outperform not only previous direct approaches, but also production systems. So thanks for your attention and see you in Bangkok at the poster session.